I think most of us are back. So I'll just start and then they'll catch up. So today we are going to use Wireshark, which is a protocol analyzer. It is a very common tool in the IT or security world. Wireshark has a lot of functionality, but mostly just for network monitoring. You can use Wireshark to do forensic investigation, for, doing packet analysis. You can use Wireshark to be able to pinpoint, if there's an attack. But we can mostly use Wireshark to really monitor the health of our network. I can use Wireshark and record, right? Take a capture of my network activity or traffic, and then use it for analysis purposes to build out my baseline. There are other tools, but having the knowledge to use Wireshark and adding that to your resume will be helpful. So I put some information about Wireshark here. They do have their own training and certifications. It is a free application. You can also integrate it as an API. Now, Wireshark, you can run it on like Kali Linux and others outside of Windows, so it is compatible across platforms. So it's definitely a useful tool to learn. So this is going to be the very basic, and if you have me for other security classes, you see it again. However, right, if you're using things like T-Shark or something in that variation, it is coming from the same open source package, so you do get the same information, but maybe in terminal only. So your packet information might not be on graphical user interface like this. It's definitely nice and pretty where it's color coded and then you can click and open things. But sometimes you can also use Wireshark inside the terminal itself, right? Like on Kali Linux or another Linux-based virtual machine or system. Okay, so we have Wireshark installed on our computer. And you can download and install it on yours if you want to scan your own network at home. So start with typing in Wireshark to search on Windows search bar. And you should be able to see the little fin, blue fin, so you can click the app. Now, when you install this type of application, a lot of the network sensing application will require you to install npcap, which is a service for Windows platform or system to be able to activate the network interface card and allow it to sense, right, the activity or communication in and out, right? So it's going to be able to kind of sniff out everything that's around it, okay? Now, an attacker can use this on a wireless network to sniff out everybody's traffic on that wireless network. And this is why public Wi-Fi is not safe, right? They can also see what you see. So we're just going to close this. We don't install update because we don't have the privilege to do that. So when you see this window, click X. Oh, it's happening to me again. It drives me crazy. Are you guys having, do you see this problem? No? Yep. It's RCCD script on my computer specifically. Okay. I'm gonna hold on 1 second, okay? I'm gonna use mine on my laptop, so it might not look like lap. I wanted to do it on your lap computer, but let me open up the lab on mine. And we're gonna share. Yeah, so you saw earlier that little yellow box, it's a script. And so it doesn't activate my network adapter, so I cannot scan anything. That happened to me every semester, and then I have to tell them to service it. But anyway, okay, so let's open up Wireshark. And on yours, you are going to see a list of adapter like this, okay? And you should be able to have a local area network connections. Whenever that you see adapters working, it gives you the little moving line like this, like the little graph. So you should be able to click on the adapter that you see. So I'm going to use my Wi-Fi, and then you can click on your adapter, the network adapter that you have. So the first step is to select the network adapter that you want to use to sense or sniff out the network. And once that happens, on the top left, you are going to click the little fin, the blue fin, which is the start. You can also use analyze and then, capture and then start. There's two options. So click the blue fin. So if you don't have Wi-Fi, you can select your network interface adapter. It should be one of the top one or the second one. Don't use the VirtualBox or the other ones that are available there. So once you select the adapter that you want to use, you're going to click. Don't use the remote one. Click start. Click the blue fin. So it's very noisy right now because it's looking at everybody's, right? Everyone on the network. So my traffic is going to be slightly different than yours because I'm sniffing out the wireless network. And you guys are on the darknet on the wired network. So it's going to be a little different. Okay. We are going to generate some HTTP traffic. So open up your browser and then, or you can click on the link that I provided, which is this one. You know that the majority of the websites are no longer HTTP. So even if you visit an HTTP website, right, a lot of the time they're going to try to convert it to HTTPS. So I can control click this and I'm going to open up this website, right? So the whole point in this is I'm generating specific type of traffic so I can actually see that service in the port, right? And if you want, you can refresh it a few times. So when you're opening a website like this is what's happening in the back. Your system sends a request through the network to the web server of this domain, right? Say, serve me the page, okay? So the router's job is to take your request, pass it through the larger network, the WAN, and then to that domain. That web server is going to say, okay, right? So HTTP have 4 steps. 1, it's going to look at the request. 2, the server is going to say, I'm about to serve you something. Are you ready? Right? And then 3, my system's going to say, okay, give it to me. And then 4, the web server is going to say, here's the page. And that happens in microseconds or nanoseconds, right? Depending on the bandwidth. So I got the page. So there's 4 steps. So that means that it has to have some kind of acknowledgement. And I want you to see it in packets, right? Now, if it converts it to HTTPS, and how do I know? Sometimes I look at the URL and that happens, or I look at Wireshark and I would see that. So once we generate the traffic, you can stop it or pause it because it's going to record a bunch of other things. So all of these are all the systems that are communicating from the time that I started until the time that I stop it, right? So I just create a network capture, okay? So let's say that you're under attack and you have this on, you should be able to capture all of the attack traffic that's coming in externally from the external network, let's just say, or even internal attack if you capture, because systems communicate back and forth, right? So you just create a network capture and it gives you the protocol here. So once you pause, you can go to the top and you can see the type of packets that you have. Yours is going to be a little different than mine. Source is where it's coming from. Destination is where it's going to, right? Who's receiving. Sender, receiver. The protocol is listed here, and when you click the tab, it organizes it too. You can filter, and then you can sort it by clicking the tab. So I simply click the packets, and on the left, you notice that there's like a bracket. When you see a bracket like that, that just represent conversations across multiple systems or between two systems. So for example, I just talked to you about HTTP. There's, requests going to the server acknowledge and say, I'm ready to serve, going back to the system. So there's like four communication elements that happens in that particular transaction. So that means that you have conversations across multiple systems, right? That would include in the packet. And then they color code it for you for the type of communication. When I look at this packet right now, you see there's an ACK. That's acknowledgement, okay? Remember that TCP requires that, and any protocol under TCP, there gotta be some kind of acknowledgement. It's kind of like you want to enter a secret door, you knock on the door and you have to, give them some kind of password. They have to acknowledge who you are to let you in. The system does that, right? And then the port value and the length and the so when you see this, everything on the lower pane, it will give you all the communication details about that particular packet for that communication. So I'm going to click the first one. I think that's part of our lab, right? Sorry, I'm leveraging between. Okay. So I already put in I captured the traffic for my URL to HTTP. Wait a few minutes, and then you can hit the stop button, which is the red square button at the top, to pause or stop it. And then it gives you the chart. So, and it might not contain all the color, right? This is just the standard. This is documented by Wireshark. And so, and it gives you some information about the columns that you see. So the packet that you're receiving are in order with the timestamp, right? The time that it sends to, and the conversation that it has. So to the first packet, we're going to look at the traffic that we captured. Okay. So right away, remember how we talked about like the vendor ID in the MAC address? It shows Cisco. How does it do that, right? It's the OIU, I'm sorry, UOI that's provided. So you see that here, okay? And then your blue, if you expand, it also talks about the frame. So if I want to know who's talking, who's sending, it tells me the source, it tells me the destination, and your first packet will be different than mine. And then the internet protocol, remember we talked about IP? It's purely for addressing. And so inside that particular header for for the IP, it has some elements. So here I know that this communication is under UDP protocol, user datagram protocol, and some system would use that. It doesn't require acknowledgement like TCP. Whenever you see ACK, there's always going to be TCP because that's same thing here. So you see 443, somebody's authenticating to HTTPS, right? Right here. Okay. So you see that, and this is the system. Okay. You don't have to pick the first packet if it's easier for you to pick another one. The whole point in this is for you to see what a packet look like on a network sniffer. Okay. So you can just select a packet. And then tell me what kind of traffic is it. So let's do an easier one that you can like, recognize, right? So let's pick this one. I pick a 443 one. You can find something like that. It's usually like a light pink, purplish. And then you can also double click to expand it if you don't like the pane. And inside it, you can see frame information. We talked about framing before, right? And then Ethernet. So, and then, you know, so you can pick the packet that you want to evaluate or examine. And then if you want, this one is a payload right here. So once the user authenticate, usually it's going to load the data. So right after that, you see how TLS is usually for security authentication. And this is an application data. You can see that. See? I think Wireshark does a better job with telling you what all of these are too now. Okay. And then once in a while you see a black one. Sometimes that's an error or a bad packet. So it resends. And then something like this. Okay, so anything with TCP you would see with an acknowledgement. Okay. So if you see application data, usually that's when it serves the data after they authenticate. So they entered that session. Like this one. And then there's DNS. So earlier I mentioned for the domain name, right? When we connect. So that's a website, adobe.io. Okay, so find a packet that you want to examine and answer the question, what kind of packet is it? Do your best. Based on the color code or, you know, what's provided you in Wireshark. It should tell you, right? You can say this is a UDP packet, you know, used by Cisco device. It says that source Cisco and it communicates with another Cisco device. Or if you want to use a 443 like this, right? You can say that this is a TCP HTTPS. I know why, because port 443 is HTTPS. And it does the acknowledgement. So confirmation between the server, the HTTP server and the client. So here the client sends to the server and that's the server IP. And then sometimes you see like, hello, that's the first transaction, right? That's like, hey, I'm here. Let's connect. And then the server would respond back, okay, I'm ready to serve. Are you ready? And the client would get the page. Okay, so we can sort by protocol by clicking protocol, which is the next step. This allows you to sort either TCP or UDP. So if I'm looking for a packet, this is useful. You see the black one that I mentioned earlier, right? See, that's an error. Okay. We click the protocol tab or the column. And we can look for HTTP packets captured. If it converts it to HTTPS, you will have to you have to note that it is. Because I think now for the majority of the time, port 80 might not even be found. And you can also filter right here. Okay, so I'll show you how you can use that. When you click analyze, you can also apply filter. And then you can specify, like I can filter from a certain source, like an IP address. And as you type, right? So if I want to type in HTTP like this, I can filter specifically for just HTTP. So you just type it into the bar here, and then you can click apply or press enter. And if I type in HTTP, I see that there are 4 packets. You see? That is related to HTTP. So when we click protocol and we might have too much information, we can apply the filter by putting in the protocol. Sorry. Here. And then they also have a pre-filled list. So you can do IP DDR equal, and then, you know, specify your IP address. So to quickly do the count, we can filter that out for HTTP. But you have to generate it to see it. Any question? You need any help with that? Why don't you use the Wi-Fi? Reopen your application. Okay. So if you guys are using Ethernet 8 and if it's slow, use Wi-Fi 6. It might work a little better. And the Ethernet one was like that too. You can try to do this is something very right? You try generate some kind of graphics. Yeah. Well, the first, yeah. And then just load the page. Yeah, sometimes the applications like Professor. Yeah. Generate the There's not that many left. Yeah. Having, oh yeah. Yeah, to sort it. So just follow the steps. Sometimes it's happen. But I'm not, because even when you do this, you would think that it's real time and it's recorded here, but it's calculated down later on. So when we visit the site, you gotta wait a few minutes and refresh it a couple of times and let it record. Even though we think it's real time, it's not. It's gonna be like, I don't know, 50 packets later that's gonna pop up. So be patient with it. It's an application, so it's there now. Yeah, so you would think that it's like a second later, but it's not, because it's still, it has to report back to the application, you see? Like it takes the capture and then bring it back. So it's gonna be like a few minutes lag in between. Yeah, so you gotta let it run a few minutes longer. Yeah, that's. Yeah, that's great. So it might not even be yours, if everybody else is on the network that, that active, if 5 of them visiting, you're reporting everybody else. It's mixed up. And yeah, and then you can tell who's asking, right? So this system is asking that, and then these two are the response, right? So it's 4 ways, like to ask, to respond, and then this system asks again. So the HTTP is, when you filter it, you see, and that's important. Yeah, if you double click the packet, you can see that as a window, and you can look at it down. Where's the, so it tells you what to put. Packet on the lower page. Yeah, so you click on the hypertext. And that gives you the HTTP packet, but it says you only have 1 packet, put it in. So click on the HTTP packet and then click the arrow next to it. Yeah, follow the steps. It tells you what to put. Anybody else have questions? Okay, so some of you said, oh, I don't see any TCP packet. Like I said, when you run Wireshark, you gotta, even when you generate traffic, you gotta, there's a couple minutes lag time because it needs to report back to the application. So you gotta let it go for a few more minutes and be patient with it. It's not real time, even though we want it to be, right? And so if you have 1 packet, show 1 packet. If you have 4, you're able to sniff out 4 or more. That's great. Okay. So how can what if I have 1,000 packet, like all the enterprise network? Well, there is a statistic options, and you can go down and you can select it. Okay. So for example, I will click on statistic and I can click HTTP and I can count up, because I'm not going to sit there and scroll through 10,000 packets. Are you kidding me? Right? My time is more valuable than that. Click packet counter and it gives you all the counts. right? That's what's cool about it. So in order to serve you a web page, or when you get a request that's generated and it's okay to serve, it's gonna give you a 200 code, right? You guys get the 404 error and stuff like that. So it records all of that too. And when we do HTTP request, and when you type in a URL, the first step is to do a get, right? When we visiting a site, that's just a get. So it counts all of that for you. So how did I get here? I click on statistic, and then I select the protocol that I want to count, which is HTTP, and then I do packet counter. And through in my capture, right, the few minutes that I capture, it count this many. Because sometimes visually, I might only see 4, but it tells me here, right? I have a total of 12 packets. So the visual here can be misleading compared to the actual packet that's counted in your capture, you know? Okay. Now, what if I want to look at other, like DNS, right? I just select statistic, DNS, and then packet counter, and then you see. Okay, and then within that, you notice, remember I mentioned HTTP, HTTPS is related to that. So you have services for the endpoints that are related. So it has related conversation in that traffic. Okay, so that's useful. Now, why is this important? Because sometimes, let's say that we want to test our network. We want to see if there's error. We want to see if there's latency. If all our systems are communicating properly, this is a good way to do some analysis, is through Wireshark. Okay, so I show you how you can do packet counter, so that way you don't have to manually count that up. Yep. Go to Wireshark, right? You're in your packet or your capture, go to statistic, and you can select the protocol that you want to count. So the question was to count up the HTTP. Select that and then go to packet counter, and this pops up, and it tells you the total right here, right? And then all the related things, you know, how many packet is doing what, right? So the request out of the 12 is 10, and the get is 2, and the search is this. So it breaks it down to the subcategory under that type of packets. And then you can choose other protocol that you want to count for practice if you want. Okay, any other questions? Okay, moving on. Okay, so we saw that you can click on the packet and then you can view the details information. So within the pane and the top, you should be able to see who's sending from, where is it going to, which is the destination. So coming back here, I need to close all my counters. And it also graphs it for you too, under the analysis and statistic. I think statistic. Okay. So if you want to evaluate the packet, you can double click and it opens this up, which is the same thing as in the lower pane. But if you click the Ethernet 2, it should tell you the source. So sometimes we get the version 6 address like this one, but it should also tell you the source version 4. So even without expanding, you should be able to see, right? Now for the HTTP protocol, it's going to give you the view with HTTP, but other protocol is going to have its own header information added to the list on the lower pane or when you double click. Okay, so write down the source and the source IP address and the destination IP address. And then because HTTP is under TCP, you should be able to see the source port and the destination port. right? And then if there's payload, you should be able to see. So if I click transmission control protocol, I know HTTP uses port 80. You see that here. So when it sends from, it's going to use 80. So when I type HTTP, that's port 80. But for the server, remember we talked about dynamic ports earlier? Guess what? Right? Because it's going to use a range of port that's in a higher value. That's what you see here. Okay. And then acknowledgement, it has a value. And sequence, you guys know what this is for, right? So packets come in all different, even though it sends, like it looks like sequential, your data is going to come in different order. As packet can sometimes slow down and get routed and there's delay. So the sequence number allows it to track the order on how it would reassemble to present down the line, because TCP, it needs to have the entirety before it gets everything open, right? So this is a relative sequence number, but this value just make sure that it's going to be in sequence down the line when it opens it back up. And then the flag, this is where you see acknowledgement act, right? Or fin is final. That's going to be the last one in that set. And so there's more. Okay. Okay, so look at the detailed information, see if there is TCP payload size. If there is, you can specify that. Payload pertains to data. Okay. And then we can expand the TCP and then look at some additional information. Now, sometimes I see students looking at a DNS packet and trying to look for HTTP. You're not going to find it. It's going to have the proper protocol, right? So HTTP is going to have HTTP details. Sure.
How can I find the source IP address?
The source IP address for the earlier questions, you can find it by just looking at this view right here, source destination. So if I select the first packet, look at this IP and look at that IP.
Oh.
You can also go to, it tells you to go to Ethernet, and then sometime it tells you the source. SRC is source and the DET is destination. So you can look at the top name and you can expand it under Ethernet too. Give it a 3 minutes. Because you're gonna see the green packets coming up, but sometimes it doesn't show visually like this, but it's still there. So give it a few minutes. And then you're gonna hit stop. Okay. I know we're coming close to 8. So all of the packet information, and then you're gonna go down, you look at some information with the timestamp. So under HTTP, it shows the timestamp information, right? How is that? Well, it tells you when that occurs. Does it have it? On this one. Yeah, it does say a little bit of the user agent. So user agents are often related to applications or the service that's used by an application. Sometimes that could be browser. And also, you know, if you don't have, it should give you.
Don't have a user agent.
Are you on the HTTP?
Yeah.
Yeah, it could be, if you don't have a user agent, you can find none. You can put none. Yeah, sometimes it would list like your browser, or in this case, I have the API for crypto analysis for Microsoft. So when you do control click, it converts that from HTTP to HTTPS and it lists that. But make sure that we click that. Let me look at this one. It should have it under HTTP for every single HTTP packet. So make sure that you click HTTP packet. But if you cannot find it, you can just say that not found. Yeah, like this one, if it's OCSP, you will not have it. Even though it falls under HTTP response.
You do that one.
So for my HTTP, right? Go to the bottom pane and click HTTP down here. Expand that and you should see. So your user agent is right here, near the middle. The method, type of connection.
What about the timestamp?
Yeah, sometimes I think it will be on the frame. Let me see. Yeah, it gives you the frame. Go ahead. Yeah. You can find timestamp under frame. I think the other version they used to include it under the protocol itself, but frame always gonna have some kind of timestamp. It tells you the date and the time and also how long that took. So see under frame for timestamp. Now you might not you might not see SYN or synchronization, but you might see acknowledgement more. So in my, you know, in the case where sometimes you would have acknowledgement in like if you look under TCP, it also show you how, you know, whether it's acknowledged, like, because TCP is the umbrella for HTTP, and you would see there's one sequence and one acknowledgement. It has to have the handshake in order to pass. But sometimes you don't see the SYN and ACK directly onto the actual top like this, and sometimes you do. It depends on the type of traffic. So not all HTTP packets the same. So I have like just the get and the response visually display here. But it does have the acknowledgement, the ACK number under TCP. Okay, so coming back to the lab, go through, you can also look at UDP. So if I go to then clear out the filter, I can filter out UDP only packets. So click the red X on the right, and then type UDP. And that's gonna categorize UDP. What's going on? Got it? Okay. Anything else? Do you see it? Does it say anything about request? What does it say? So there's, so it just said, I think you only have. Yeah, yours should say get.
No, it's like.
Yeah, I think it's request. It's only the server information about that. I don't know how to show on here. You have to. But it's the operating system side. Okay.
So well,
You can just say that you can find it or not family. No, it should say the date. So click on the frame, go to the top. The date. Timestamp, you guys look at frame and under the date. Okay, so UDP information. We should be able to see UDP after we filter it. And then you can also use the statistic. It walks you through that and look at how many. So this is cool because you can follow the conversation and also look at UDP casts. So I can go back here, go to statistic, and then I can go to multicast. We talked about that earlier, right? So I want you to see that systems, they do use multicast for streaming, and this is what it gives us. Okay? And then we can also examine how many systems for the TCP. I just want to make sure that I'm following, so I'm not straining off here. Okay, so for the next one, we are going to look at endpoints. Oh, endpoints are just systems that are connected part of our network. So your laptop can be an endpoint. Smartphone can also be an endpoint. So we can count that up real quick. How many endpoints are on our network? So go here. And then select endpoints, and then it's gonna give me your last name. Okay. Okay, got it. All right, so here it gives you the number of packets and so on. Okay. Yeah, we might not even get to Cali today. I forgot that this is long. I'm always over planning, but if we don't, will do it next time. Okay, so you can find the endpoint, so, and the multicast information. So that gives you the number of packets that's transmitted. You can also look at the port. Okay. So I think this particular version, let me see. Yeah, so once you get the endpoints data, you can also look at the ports. So, am I on the endpoints? No, this one's not. So over here, it gives you all the packet information, the address. And now sometimes, they also change the graphical user interface, so you might lose, they place it somewhere else, and it just from version to version that sometimes that you have some changes. So it asks you to look at the TCP tab, how many endpoints showing how many packets, and then the port tab to look at the port to see if you have packets that are from port 80. It should say port B. So UDP is the next one. And then TCP. So when you click TCP, if it populates, you can select the ports and be able to do that, right? Yeah, on my capture, I didn't have much of it should though, which is strange. Oh, let me clear my filter. Okay, so statistic endpoints, TCP, and yeah, port. So if you click the port, it would sort it from 80443, so I should see. And then for UDP, same thing. So we know that DNS traffic is UDP and then others, as you can see there. So make sure we follow the steps for the lab. It should walk you through on how to get the information. And then you can also look at IP types. So under IP version 4, we can click IP protocol types. And it would separate between UDP and TCP, and it gives you the count for that. And the rate. So that's gonna give you the throughput for your packets. So if you evaluate this for performance purposes, that's ideal. Okay. So if we can wrap up part A today, that will be okay. I was stressed out about writing part B, but ultimately we might not even be able to get it done. Bye, see you later. Okay. So if you can finish up with part A for the Wireshark, we're good. And then I'll do attendance now. Okay. So after you have written down all the information for your traffic, percentage for UDP, so a network analyst will have to gather all of this information, right? For your enterprise infrastructure. And then sometime you also have to evaluate the cloud, like your remote servers and all of those things and do some analysis. But the cool thing about Wireshark is it does give you a lot of the statistic foundation already. You just have to interpret your data. Okay. And then we'll save B for the next time. Any question? So I'll let you work on that and then let me stop recording.